This is a Spot Welder. It cost me $16. It was from Alice, 1101983. It's supposed to be 6 to 18 volts. The capacitor modification's already been done. And this capacitor modification is to hold up the control voltage to the MOSFETs. It's not to reinforce the spot weld. Trying to use this capacitor to hold up the battery voltage while you're doing a weld is like a fart in a tornado. The soldering I have to do is to install the sounder. It is polarized, and the long wire indicates positive, and the silk screen indicates where it goes in the board. The other thing I have to do is heat shrink the tubing on these welding probes, and then make connections. I guess the positive could live down here on the underside of the board, and the probe could live up here. It's just a pass-through for the positive. I've got 3 screws, 3 nuts. This is pretty thin compared to some I've seen, but it came with the welder. To use this board, I've got some heat shrink out, and my battery, all of them use this kind of fitting. That requires this. And this, and it is number 10 gauge, was supplied with a ring terminal crimped on each end, which I've cut off. Because this is a common terminal, and this is the input terminal, I've cut these 2 lengths so that when they're hooked up, they'll come out evenly. So now I'm going to have to attach this fellow to the end of these. I'm going to shrink these together with this piece of heat shrink. I've already put a piece of heat shrink on this. Now, in order to solder this, I'm going to use one of these Weller heat guns. Well, it's not really a heat gun, it's a soldering iron. This is actually a secondary turn of maybe only 1 turn around a primary. It's fed 110 volts. Big heavy thing. Now, I bought this on eBay a long time ago. It was I haven't opened the box until today. The wrapping paper was marked 2013. Came with a brand new tip. A roll of this, which is commonly used for pipes, and a tin of soldering paste. And I believe this is corrosive. Clean parts to be soldered, apply sparingly, then solder. Contains zinc chloride. I haven't used one of these for maybe 30 years. It does apply a lot of heat. I don't know what the wattage is. It's not marked. May have been marked in this tag that's missing. I did get the instruction manual for it. And this is really great. I've made a few thousand of these as punishment, actually. I stood in a 55-gallon barrel until it was full of these. This is a long Western Union splice. And they could be soldered or left unsoldered. They were used for overhead suspension lines, catenary cables. I don't see a wattage. I do see there was a standard and heavy duty. But I don't see any specifications for wattage. That solder job looks pretty good. Now that the joints have been soldered, we'll put some heat shrink down there. I've applied the heat shrink to the welding probe. So there's the welder fully assembled welding probes, battery adapter. The only thing left is the sounder. The sounder is polarized, and the long lead, as I said before, will go in the positive. The hole labeled by the positive marking on the silk screen. I intend to cut a little square piece of plastic and put it maybe on 3 standoffs. I'm not sure if I can get a standoff in here. If I use non-metallic standoffs, I guess you can get it in here. There's an awful lot of wattage available, a lot of damage to be done sliding this around on a workbench, especially if there's little, like a transistor. I managed to get 3 out of 4 standoffs in. The 4th hole is obscured by the sounder, believe it or not. So I hooked it up to the battery, and I got a green light. There's a push button here. That does not seem to do anything. That's worrisome. Oh, there we go. Okay, successive pushes, different counts. 5, back to 1, and the light goes out. So apparently it powers up at 1, or it powers, well, we'll disconnect it and we'll power it up. Okay, so it powers up at 0. 1, 2, was that 2 or 3? Maybe that's 4. 5. And off. So I think it's 5. 1, 2, 3, 4, 5, and off again. Where did my nickel wire go? Here we go. Just cut off a piece of it. A couple of pieces. We'll put it at 3. There's 3. Hold them down with a probe. And it's spot welded, but it doesn't seem very good. Certainly can't tear it apart. Oh, I can break it apart. Okay. Put it up to 5. Maybe I should use something harder than the mat. Just lay it on this can. That probe on. Okay, I think it's welded clear through. I can't do anything with it. And there we go. Can's damaged a little bit. But now this is very thin nickel, 1/10 of a millimeter, 0.1 millimeter thick. I am using a fully charged, oh, this is only a 7-volt lithium ion. Let's try my 12-volt. Or 11.1 volts. So now I've got what was fully charged 2 weeks ago, an 11.1 volt battery. That time it came on with a 1. May have to do with this capacitor being discharged. We'll run it up to 3. That was impressive. And I would say that's welded. Try a 4. It's actually welded to my aluminum can, or to my steel can. So that's fine. Now it's not like I danced down a row of batteries, welding 2 welds or making 4 spot welds on each battery, but there is absolutely no felt heat anywhere. What was it, $15 board from Alice? You have to look back at my mailbag. So I'm pretty impressed. It does exactly what he said it was do. I should have taken this off. Make it a little bit louder. Let's see how much louder. Oh yeah. So I don't know anything about spot welding, but it seems like it's serviceable. It worked with the 7-volt battery, and it works much better with a 12. And it is advertised for use with a up to 18 volts. The reason I got into this and invested $25 or $50 in batteries, between $15 and $20, I bought 3 of these, all different brands. So what's that, $60, $70? Is because I want to repair this. I want to put a new battery in this. I could have bought this cheaper than the investment in all this. It's the way of life. Well, your brain is modified when you're drinking. You say, I can fix that. Well, yeah, maybe I can. So, the next video, I'll use this to repair this. Maybe. So there we go.